And you are welcome. And we are going to solve a new problem related to electric flux. The idea of electric flux is quite important from our point of view. So, we are having problems related to this idea right now. And this time we got two point like charges of values q and minus 3q. That means 2 point charges are at a distance d in vacuum. Well, determine the electric flux through a disk of radius d by 2 and at a distance d by 3 from the charge q. So it is at a distance 2d by 3 from charge minus 3q. And the center of the disk is on the line on the line segment which joins the two charges. That's right. And the plane of the disk is perpendicular to the line to the line segment. So if we fix our eyes at the problem itself, mind the charge q and minus 3q are placed at a distance d in vacuum, and there is a what we call a disk like this, okay, at a distance d by 3 from the charge q, and its distance from minus 3q is 2d by 3, because the distances between these charges distance between the charges q and minus 3q is d. And here is the disk is having the radius equal to d by 2. Yeah, it was. And we need to find the flux passing through it. One thing I noticed here, that the flux due to charge q passing through the disk in this manner, and minus 3q also in this manner. So we need to add them, fluxes. Flux from charge q that passing through this disk needs to be added with the number of field lines passing through this disk due to minus 3q, charge minus 3q. And I'm going to plan something. I have a different plan. I just put this charge q here. In this picture, I put the charge q here, and this disk you see here, I placed it here, so that it looks like a cone. The disk becomes the base of the cone, and point q I placed at the vertex of the cone. And I'm willing to find out flux through this flux due to charge q from this base of the cone. And how can we do this? We can do this quite easily, but I have discovered earlier that this distance is going to be d by 2, and this distance is d by 3, and this distance is d by 2. So I have just placed a sphere over this cone, covering this cone, and I would like to know the radius of this sphere as well. And if I call this r, r is simply going to be, using Pythagoras theorem, it's going to be d by 3 square plus d by 2 square under root. And I get the result as under root 13 divided by under root, this is basically under root 13. Okay, under root 13 by 6t. This value of r I get after solving. And what can I do to find the flux passing through this base of the cone due to the charge sitting at the vertex of the cone, and that is charge q. If you remembered earlier, you need to find this length to find the flux through the base, and this length is nothing but this is r minus d upon 3, this length. And we earlier prepared a ratio, that is the flux passing through the base of the cone, that I would like to write south flux we needed to find, divided by the total flux covering the all of this thing, and whose center is at the point charge q is sitting, and this whole sphere. I just put this charge q here at the center of this sphere so that I can find the flux easily. And so the total flux passing through this to this sphere, I know it is q upon epsilon naught on the basis of Gauss's law, and this south flux and flux passing through the whole sphere will be the ratio of two lengths, in which one length is r minus d by 3 and another length is 2r, the diameter of the sphere. And so after you can put the value of d here, you can get d from here in terms of r, and you can put 6r upon root 13 in place of d, and you are going to get this result equal to 0.223, and that means you can tell here that the flux you need will be equal to 22.3% of flux passing through the sphere, and that is obviously q by epsilon naught. And in the similar manner, you can find the flux passing through the charge, passing due to the charge minus 3q, and you simply need to add them, and in the end you are going to get the result that the total flux due to both the charges q and minus q passing through this disk is going to be 0.523 q by epsilon naught. You can check yourself. So thank you for watching.